I'm Ashwin Vasavada, the project scientist. And on this top slide, you can see that our deputy project scientist is Dr. Abigail Freeman. So we're really excited to have her join the team in that role. And she replaces Joy Crisp, who retired after a couple decades of really great service to the Mars science community. So I also want to thank Joy. What you're seeing here is the rover at a drill site that occurred in the last month or so, just below that slab of sandstone in the back that cuts across horizontally, which is a major unconformity that we're now exploring on Mount Sharp. Going on, please. So our one slide COVID update, I wanted to just mention that we are now 100% working from home operating the rover. We went remote on March 20th, and about 99% of our roles were remote, but we still needed to have a key role on site at JPL. But in the last week, we're even able to get that key role off lab. So for about 3 weeks, and especially in the last week, we've been operating completely remotely. And that required a lot of innovative thinking by the team in how to communicate effectively and how to do the robotics part of the job safely without the quality of the workstations and tools and being all in the same room that we're used to at JPL. And I bring that up, not just to give you an update, but also just to remark on the incredible dedication of our engineering and science teams that they're now working 10-hour days because we're a little slower at operating in this mode. And that's not sustainable, but they're totally willing and wanting to do it, while we learn how to operate remotely as fast as we were able to before. Next step, please. Okay, so this is just a brief status on the spacecraft. And the key point there is that we can do everything basically that we did in our prime mission, with only a few exceptions. So, after 7 years on Mars and in our third extended mission, we have 10 out of 10 instruments working. We're very fortunate to have that. So I list some of the minor loss of functionality that has occurred in those bullets below, which you can read at your convenience later. I'll just highlight the last one there, that the RTG power, our nuclear power source, is about 60% of that at landing. But we actually had some excess energy at the beginning that we weren't using. And as we dropped below that, we were able to work hard at getting increased energy efficiency and model our heating better, electrical heating better, and many other things that allowed us to follow that RTG degradation curve down without actually decreasing what we're doing on Mars. And we think that we can sustain that. We can continue to stay below what the RTG puts out until about FY22, when we'll have to slow down based on the RTG. Next, please. Okay, this is just to make the point that we continue to engage both the science community and the public. So on the left, you can see a chart showing our publication count by first authors who are on the MSL science team, and then the blue curve, which follows with a slight lag that's due to the first publications of results taking 6 months to a year after landing. But since then, the external community uses our data and publishes papers on MSL related topics using MSL data nearly as much as the actual team does, which is remarkable and just shows that not only is our team benefiting from what we're doing on Mars, but the broader Mars science community is as well. And in terms of the public, we continue to have a lot of great response from the media and from the public and social media, which you can read about on that right-hand column. But we're still making, getting millions of hits on YouTube videos and multiple millions on things like Twitter posts. Tweets, I guess, is what the kids call it. Next. Okay, and this is just a really great press release, public release we had a couple months ago, where we took our largest and highest resolution color panorama that we've ever taken in a mission over Thanksgiving, when the rover had some free time and the team, the team wasn't keeping it busy with other things. We were able to take 4 days and acquire a 2 billion pixel panorama, and it just is a wonderful public outreach product, as well as, of course, a lot of good science information in there too. Next, please. Okay, so here's our traverse map. We have driven 22 kilometers since landing. Up in the upper part of the image is where we landed. We spent a couple years driving across the plains. We got to the base of Mount Sharp, about where that Gobabeb word is, a little higher than that. And then we've spent the last 5 years or so slowing down, doing very detailed work as we're climbing through the stratigraphy of Mount Sharp to where the blue star is on that map. Next, please. What you'll see on the next chart is a kind of graphic visualization of what it's like to climb a mountain with this rover. And we spent the prime mission mostly out on the plains of Gill Crater, and what we now call geologically as the Bradbury Group. We entered the strata of Mount Sharp at Pahrump Hills. Some of that was overlain uncontrollably by the Stimson Formation, and then after we got across that bit of Stimson, we really began climbing the mountain through the Murray, which is the main stratigraphic formation in Mount Sharp, crossing the hematite unit and Vera Rubin Ridge, and now reaching the clay-bearing unit where we are now, having climbed 410 meters of elevation since landing, with 340 of that being on Mount Sharp, Aeolus Mons itself. And here's a key result. This is probably the biggest result of the whole mission, and our legacy here is that, we've found a place where the depositional environment recorded over 340 meters of strata has been primarily lacustrine, with only minor intervals of lake margin and some aeolian strata. So that alone just speaks to the persistence of the habitability and liquid water in ancient Mars in the early Hesperian. Next. The next slide just shows how we've analyzed samples from 25 drill holes. The thing I'll point out here is, these are all taken by the same camera, processed the same way under similar lighting conditions, and you can see the variety of colors. And that speaks to probably the second biggest, geological legacy of our mission, which is even with similar sedimentary starting materials and similar depositional processes, primary depositional processes, there's been a lot of diagenesis that we've been able to explore, and we see that primarily in the mineralogy. Often the chemistry can be very similar between these sites, but because we have the capability to explore the mineralogy, we can also unravel all the diagenetic overprinting that's occurred, which is something that's going to be important for understanding all of Mars' surface. Next, please. So what did we propose in EM3? We proposed to study the clay-bearing unit, which is this year in FY20, and we're almost, getting into, we're well into progress on that. We'd like to go to the clay sulfate transition that's coming up, and then also a place called the green hue pediment on the next slide. I'll just briefly highlight what we've found in the clay-bearing unit. This is an image of the clay-bearing unit. One thing is that we weren't sure, because this clay-bearing unit was first mapped from orbital spectroscopy, we weren't sure if it actually was something that was, pasted later on Mount Sharp. It was detrital. But we found that the strata are conformable with the Murray Formation, meaning it's a continuation of that 300 plus meters of lacustrine strata. It also has some brief, some cross-bedded sandstone facies as well on the tops of those ridges that you see in the clay-bearing unit. And again, another really key part of what we've been able to do is trace strata laterally over hundreds of meters. And again, similar, similar depositional environment, but very different expression because of the diagenesis that's occurred. The same strata are in the clay-bearing unit and the Vera Rubin Ridge, in the softest rocks we drill and the hardest rocks we drill. And that's all due to variable diagenesis. We've also found 30% clay mineral abundance, which is very consistent with expectations from orbit, and we found a wealth of organics in the clay-bearing unit. Both the native sulfur-bearing organics, which are better preserved over time, we believe, and higher molecular weight organics. Next, please. We would like to study the green hue pediment, which you can, I'm going to have to blow through some of these for time, but the bottom line here is this is a major unconformity. The sandstone capping unit that overlies the pediment surface itself cuts across the clay and sulfate-bearing strata, and itself is overlain by the Scetis ridge, which may be a product of fluvial deposition or a debris flow from higher on the mountain. So you have the lacustrine strata, they formed, they eroded, lithified, eroded, overlain by the pediment, then overlain by even more water. And this is just a huge climate signature that we want to be able to explore. Next. The other part of the mission that we still are really looking forward to, and this we knew a lot more about from orbit before landing, was this clay sulfate transition. We are right at the end of the clay-bearing unit now and the beginning of the sulfate unit. And the next few years, that's going to be a very important major environmental transition for us to study with the mission. And so I'm going fast because I really want to make a few very important points in my last couple slides, which speak to, honestly, the team feels a bit under a crisis now because of the funding situation. And, MRO talked about that, and you'll hear even more about that from Odyssey. Going on to the next slide. What this slide shows is the number of shifts that our team can execute every year over time. And when we landed and we were all living on Mars time, synced up with the Mars clock, you can do up to 355 shifts a year. And when we went to Earth time to relieve the team of staying up all night, you could still do 260 shifts a year. For the past few years, though, we've been doing 16 shifts a month, which is a really good compromise because you take weekends off, you only command when you have data from the last sol, and it just is sort of the sweet spot in operating a rover. And we were able to do that, fortunately. The RTG supported that, the money supported that, but then we got an unexpected 13% cut last year where we had to reduce below that 16 shifts a month to 14 shifts a month, and this is purely for budgetary reasons. So we were already leaving 25 shifts, undone on Mars because of money. And this year, with the president's budget having an additional 20% cut beyond that 13% cut we just had last year, we know we've lost a third of our budget, and we're looking at operating at 125 shifts in FY21, which will leave almost 40% of the capacity of the RTG and our team unused. And this is a big morale hit for us. We don't know why it happened, and we really hope that you'll continue to support us as we try to hope that this we get some relief here. And planning cycles translate directly into how much we can drive and sample. So I'm not just counting shifts here. I'm really saying we're not going to be able to get done the science I just described. So on my final slide, I'll just note that in the senior review process last year, we really came out well. We got a 5 out of 5 on scientific merit with no weaknesses found. The senior review subcommittee had some of these quotes here, which you can read, but they actually recommended that we increase our ops shifts because they recognize that the RTG isn't going to last forever, and that we have this really great asset on Mars that's degrading. So in summary, I'll just point out that NASA and the Mars Science Community have a great fortune of having this flagship rover in great shape with an experienced team, and are ready to further advance our study of ancient habitability. There's a window that's closing to use Curiosity because of the RTG, and the proposed FY21 funding would really force probably one of the two major objectives, either the green hue pediment or the clay sulfate transition, into beyond FY22, when power and funding are even more limited. So I don't like to be a bearer of bad news, but that's where we're at, and we really appreciate your support. And thank you very much.
Thanks a lot, Ashwin. Appreciate it. So again, to keep on time, we'll just move on to the Odyssey talk, but I would encourage everybody to put questions into the chat window, and hopefully, Ashwin, you can stick around a little bit to answer some of those questions.